Hi guys, so today we're going to go over the average rate of change and the zeros of a function. So starting it off, just remember that the average rate of change is just another way to say slope. And the slope formula, slope is notated by the variable m, is just rise over run, meaning y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We'll go over the zeros afterwards, but we have an example here of an average rate of change. You're given the function and you're given the x values. So the biggest thing is just to make sure that you label which one is x sub 1 and which one is y sub 1, x sub 2, and y sub 2, because that seems to be the biggest mistake I see if you guys have the slope formula. So we're going from x equals -1, so that would be x sub 1, and then we're going to x equals to 1, so that would be x sub 2. So really in math, nothing changes too much in the beginning. So if you have the x values, remember if you want the y values, if you have the x values, you plug them in. Plug them into the function. F of x is just another way to say y. So if I want to know what y sub 1 is, I am going to just replace the x's with x sub 1, which is -1. So instead of 3x to the third power, I'm going to replace x with -1. Always remember to replace anything in parentheses. Anytime you substitute any number, expression, make sure it's in parentheses. And then minus 2x squared, so that would be minus 2 times -1 squared plus 1. And the reason why about the parentheses is because in the calculator, if you don't have them in parentheses, sometimes the answers come out wrong. Like if you type in -1 squared without a parentheses, it'll come out as -1 rather than +1. Also, it tells you what the exponent belongs to. So if it's in parentheses, that means that's what the exponent belongs to, which is the -1. Using Pemdas, parentheses, exponents, multiply, divide, add, subtract, we go in that order. We're going to take care of the exponents first because there's nothing to do in the parentheses. So -1 to the third power means -1 times -1 times -1, which is just -1. Bring down the 3. Minus 2 times -1 squared. Again, -1 squared is -1 times -1, which is just 1. And then from here, after exponents, we multiply. So we have -3. -2 times 1 is -2, and then bring down the plus 1. Pemdas states that when you're just adding and subtracting, you go from left to right. So -3 minus 2 is -5, and -5 plus 1 gives me -4. So we have x1, we have y1. We're almost there with the formula. We just need to know what y2 is. Since we already have x sub 2, which is 1, to find y sub 2, I'm going to take the function and replace all of the x's with x sub 2. So remember, in parentheses, we take care of exponents before we multiply. This one's a lot nicer since we're just cubing 1 would just be 1, and we're just squaring 1, which would also just be 1. So y sub 2 gives us 3. -2 times 1 is -2 plus 1. So left to right, we have 3 minus 2, which is 1, and then bring down the plus 1, 1 plus 1, which is 2. So we have y sub 2, y sub 1, x sub 2, x sub 1. So just make sure, again, label which is which. We're going to plug it into the formula, which I'm just going to write up here. So y sub 2 is 2 minus y sub 1 is -4. The double negatives I'll worry about later. I'm just going to substitute to make sure that I am replacing each variable with its correct value. So x sub 2 is 1 minus x sub 1 is -1. And then from here, 2 minus -4. Two negatives make a positive, so 2 plus 4 gives me 6. All over 1 minus -1. Again, the two negatives make a positive. So 1 plus 1 would give me 2, which my slope or average rate of change from -1 to 1 would equal 3. Okay, now the zeros of a function. So the zeros of a function are just the x-intercepts. Algebraically, they're when you're solving for x. And remember that the first step whenever you solve for x is you change y to 0. So x-intercepts are points on the graph on the x-axis, because if ever you look at the x-axis and you just identify the point, the y value is always 0. So keeping that in mind, if you look at this graph and I just ask you for the zeros of the function, notice that the zeros of the function are just the x-intercepts, meaning the points on the x-axis, because any point on the x-axis is where y is 0. So all of these words correlate together, zeros, x-intercepts, when you're solving for x algebraically. So in this case, the zeros would be all of these points on the x-axis. And I'm just going to make an example out of this one. So if I were to write this point out as an xy coordinate, it would be 2, 0. So notice that the y is always 0 on the x-axis. So when they ask for the zeros of the function, it would be -5, -2, 2, and 5. So there's no real work when it comes to finding the zeros of a function if they give you the graph. You just have to know what to look for. Just to kind of add on to this, if I were to ask you for the slope or the average rate of change of this function from x equals 0 to x equals 2. Just notice here, so I'm looking for the slope basically from x equals 0, which is here, to where x equals 2, which is here. So from here to here is where I'm looking for the slope. Notice that I already have the y values. So if I were to use the slope formula, y2 minus y1 over x2 minus x1, remember that x sub 1 is 0. So this point where x is 0, what is the y value there? That y value is -2. So this would be x sub 1, y sub 1. And since I'm going up to where x is 2, which is right there, we've already labeled that point as 2, 0. So this would be x sub 2, y sub 2. So again, less work when they already give you the graph, because you technically already have the values, and now you just replace those variables with the values given. So remember to label. Y2 is 0 minus y1, which is -2, all over x sub 2, which is 2, minus x sub 1, which is 0. So here I have 0 minus -2. Again, that would give me plus. So 0 plus 2 is 2, over 2 minus 0, which is 2. So the slope would be 1. All right, guys, that's everything. I hope this helps.